Hi, and welcome back to the Azure Database for MySQL monthly webinar. I'm Shreya, Aithal, and co-hosting this session with me is Jim Toland. For those of you who don't know, Jim has been supporting the webinar production on the back end ever since the start of the series. So really excited to have you on screen, Jim. Welcome.
Hey, thank you so much, Shreya. Yeah, it's kind of a different perspective here being on screen, but I'm really happy to be able to help out in this way.
Thanks, Jim. So, folks, we are live today on YouTube, LinkedIn, and Twitch as always. And for those of you who missed any of our previous episodes, you can check out the recordings on our YouTube channel. Our handle is at AzureDB MySQL. I know we've got some interesting, exciting topics planned for today's webinar. So, Jim, could you walk us through the agenda?
Sure. So the agenda for today's episode, like some of our previous ones, we're going to have a couple of deep dives. And the first thing we're going to cover is a winning strategy for migrating from Azure Database MySQL single server to flexible server. And we've got Gyani Sinha here to help us out. And then we also have a topic on connecting to Azure Database for MySQL flexible server in a private network configuration. And we'll have Ravi Shankar on do that for us. And then finally, as always, Shreya will share our upcoming roadmap with you.
Thank you so much, Jim. Folks, if you have any questions or feedback during the webinar, or if you just want to drop a hi and let us know what you want to hear from us in this session or in the upcoming sessions, please drop it in the live chat window, and we'll address them as we go through the session. Yeah.
I was just going to say, we're also going to have our product expert, Sadish, on the phone or in the chat window, I'm sorry, and he's going to be able to help us address any questions that happen to come in during the course of this. So be aware that we've got Sadish there to help out. Thank you, Sadish.
Thanks, Jim. Now, let's get started with the very first section. Azure Database for MySQL single server will be retiring on September 16th this year. If you haven't already, it is high time you upgrade to flexible server right away and make use of all the benefits flexible server has to offer. So inviting Gyani Sinha, Senior Cloud Solution Architect at Microsoft, to share with us a winning strategy to migrate from single server to flexible server. Hi, Gyani. Welcome to the webinar.
Thank you, Shreya and Jim, for having me. I look forward to share as well as learn from this amazing session that you do month on month. And my good morning and good afternoon and good evening wishes to all joining from different time zones. I am Gyani Sinha, a Senior Cloud Solution Architect at Microsoft, covering data and AI. And today I'll be sharing a bit about how to go about the migration, what is the best migration strategy when you look for migrating from MySQL single to flexible server. So we have put together all these experiences and lesson learned from various implementations to help you in your migration journey. So in the next slide.
Yep. Thank you, Gyani. We're gonna go ahead and let you take over now at this point.
Sure. All right. So in the next slide, we will start first with a recap of the foundational question, which is why should you migrate from single to flexible server? And exactly what Shreya mentioned in the beginning of the session, that single server is on the retirement path and it's scheduled to be retired by September 16, 2024. There is also no version upgrade which will be available on the single server. So we strongly recommend that you migrate your single servers to flexible server at your earliest opportunity. As you can see, as per recent stats, we still have 32K database instances left to be migrated. So if you represent any of those, this session is absolutely for you. Also to notice that single server architecture can no longer accommodate all the new feature functions or security enhancements that we are bringing to the flexible server. So with your migration, you would also be able to take advantage of all the latest benefits in terms of security, resiliency, performance, and cost optimizations, etc. That's not all. In fact, flexible server exceeds customer expectations and offers various enhancements such as flexible maintenance, enhanced monitoring, accelerated logs for business critical service tier applications, and much more. So I would recommend to stay tuned till the end of this session, where Shreya will share more updates about what's coming in the roadmap for future. Right. So let's move to the next slide and let's look at various migration considerations. So when we embark on the migration journey, there are various factors that can influence the success of the migration effort, right? So the secret sauce is how much of the details that you have covered and evaluated as part of your strategy. So before you set out on this path, it is also essential to carefully consider those factors and understand what could impact your migration approaches for specific to your use cases. So first, I would start with cost and sizing, which are one of the most important considerations. With flexible server, you can take advantage of stop and start features, burstable service tier, and reserve instances, for example. So I would strongly recommend to estimate the flexible server cost with the help of pricing calculator that we provide on Azure pricing page, and review those estimates with all the relevant stakeholders to have the buy-in, right? On the sizing aspect, we offer different service tiers, for example, burstable, general purpose, and business critical. So for choosing the right tier, consider, for example, the vCores, the memory per vCore, storage size, database backup retention period, your current usage, and also the overall business requirements. The compute tier, the compute size, and the storage can, of course, be changed after you have created your flexible server. But regardless of the SKU of your single server, when you are migrating, you have to at least choose similar configurations of your current single server when you migrate to the flexible server, so that the memory and everything is optimized when you migrate to the flexible server. The other important considerations are, for example, version compatibility. When you're migrating from same server of the MySQL to flexible server, it is typically ideal and simpler. But when you have to upgrade as well as part of the migration, there could be various compatibility issues that could arise, and there are various reasons for that. It could be, for example, deprecated features, it could be change in default settings, or it could be, the database system behavior has been changed a bit in the flexible server. There's a new architecture, so you have to take into those considerations when you're migrating. We will see an example of that in the demo later today. Of course, while doing that, you should also ensure that you have done your comprehensive testing and validation, probably in the low environment first, to identify any compatibility issues. If you need to modify some of your code bases, maybe some functions are not supported, then you have to modify them before you migrate for a cleaner, smoother migration, right? And regardless of the migration approach implied for workloads, the next important feature is also important, which is your potential risk of the downtime. Your business could be impacted if you have not planned that well. So this is often a result of necessity to pause an application or dataset to guarantee the continuity of its copy, validation, etc. It is also important to connect with business and application teams to inform them about your migration plan and analyze any impact about the downtime during the cutover, right? Next important consideration you should also factor in is about the network connectivity requirements. In fact, I would also say this is one of the most important one, because before you're creating your flexible server instances, whether you are using public endpoint or whether you need private endpoint, you have to get that in before you try to move your data, because data exfiltration risk, etc. are there. So networking considerations are super important. Of course, there are several other factors which also influence the performance of the migration. Of course, the size of the source databases, the amount of data to be transferred, the network bandwidth, and the latency between the source and target. There could be various other configurations which could affect the performance. So it is also important to consider these factors before you start migrating, right? Lastly, resiliency is an important aspect. Now with flexible server, you have two HA deployment models. You have zone redundant and you have same zone HA. So you have to consider the trade-off between the availability and performance and cost when you choose either zone or same zone HA, right? So let me take an example for zone redundant HA, which provides highest level of availability and isolation across multiple availability zones, but it may incur higher network latency because they are in different zones. Whereas in same zone HA, it does provide high availability with single availability zone with lower network latency, but it does not protect against zone failures, for example. So you have to consider trade-off depending on your business criticality and applications criticality, and take this factor as in. So these are the most important consideration. I would move to the next slide and let us review some checklists that we have and the prerequisites around that. This is not an exhaustive list, but we would see some of the points one by one. I have covered most of the points here about the cost and the sizing, the different options that you get. But beyond that, you also have to look at other factors. So let's say, let's click a couple of times to go to the last factor. And I have covered the version compatibility, networking and security, resiliency. Also, the last is the access and privilege. I would like to specifically call out these. For example, with your migration approach, you have to ensure that the users who are responsible for migration have necessary privileges in the first place. If in case you are using data in replication, you have to create a dedicated user in source databases with replication permissions to read and apply changes to the bin log on the source server. So what happens if you have increased bin log retention on the single server, that ensures that the bin logs are not purged prior to the replication changes. So that is also an important checklist to review before migration. Now, let's look in the next slide about what are the tools we have when we want to migrate exactly, right? So broadly, I would say there are two broad categories of migration approaches. Either it is offline migration or online migration, as it's illustrated here. And there are several tools to do each of the style of migration. Within offline migration, the source server is taken offline and a dump and restore of the databases are performed, right? Typically, it is a preferred choice because it is simple and easy to execute, less dependencies on real-time impact, etc. Whereas online migration is the best choice if your applications can only afford minimal downtime. Migration of most of the OLTP systems, for example, your payment processing, e-commerce, etc., may fall into this category, right? However, online migration is more complex and requires more planning and testing than offline migration. So you need to have that consideration, whether your cutover window is well timed or not, is short enough to do the migration, whereas not long enough so that your business applications are impacted. In terms of the tools, as you can see, there are multiple tools available at your hand to use. I would take a couple of examples. For example, if you are migrating single server database workloads, which has basic or general purpose SKU, and the database storage is, let's say, less than 10 GB, for example, and there are no complex features, you may simply use the in-place migration tool, which is available within the MySQL experience. And then if you are looking for more performant, large size workload, such as in the order of more than 500 GB, MySQL import works better and is more performant for such workloads, right? It's suitable for all sizes, to be fair. And there could be scenarios where you may have to migrate cross-region or cross-tenant. And you may also prefer more UI and user friendliness experience for migration. In that scenario, you would prefer rather Azure Data Management Service, which is a fully managed service from Microsoft. I must highlight at this point that it's important that we consider all the known issues and limitations of the migration tools that you choose to use. And in the product documentation, you would find about each of those options and their limitations, if any, for example. So must refer to those as well. So let's move on to the next slide. We would talk about what are the typical stages of migration, right? So we know typically you start with discovery and assessment of your existing environment. So if there are any application dependencies, SKU, the database sizes, resource usage, version parameters, server parameters, network configurations, user access, whether you're using read replicas, etc., is important to have those detailed assessment of existing environment. And then for discovery, with the next click, we would see that the discovery of existing single server details, we have a tool. For example, if you have access to Azure Resource Graph Explorer, of course, you would need to have access on the subscription where the single servers are and read access on the Azure resources. You could run this query to get a gist of what applications you have, the type of applications, the priority, the tier that you're using, the CPU usage or the memory usage, etc. All these, the versions, etc. So you can have a list of your existing database instances or servers that you have to migrate. So start with that. and then validate and finalize any networking connectivity strategy, your downtime with your stakeholders, estimate the costing that we have discussed so far, and review basically all the migration readiness factors, and then perform smoke test or pilot migration before doing the actual migration for production, right? Because it is important to identify any teething issues or any compatibility issues. And then once you have done the migration, perform the validation and data integrity checks to ensure that the data is migrated properly. And that's where you also get an opportunity to further monitor, observe, and optimize your estates, and think of using Azure Monitor tool, for example, to monitor the health of your Azure databases which has been migrated, and then maybe managing your caching applications, or use insights to understand performance and utilization. And further, whether you want to make use of the new features with flexible server to handle certain business criteria or business applications, you can explore those optimization opportunities as well, right? So let's move on to the next slide to sort of understand a very high level overview of the migration steps. So you have your single server on your left, and you start with the discovery assessment of your current environment. And then you pick, based on those evaluation, you identify the right tool, your favorite tool for migration. Then you migrate the schema and the data. And then once it is migrated, if there are any remediations to be done, any optimizations to be done, you do a couple of those iterations until you achieve the optimal performance, right? So let's see in the next slide on if we have to use one of these tools. So today we will showcase MySQL import CLI tool, which is very performant for big size databases migration. So we'll be showing you the demo for this, and I would just highlight that this uses a snapshot backup and restore technology to migrate the data. And I have Neil D'Souza helping me with the demo prep, so shout out to him. And this would be a pre-recorded demo considering the time constraints. We'll show you how easily we can migrate and also upgrade to higher version from 5.7 to 8 along with the demo. So it's time for demo. Right. So here is a resource group under which we have a single server, which has been provisioned already in East US. And let's look at some of the properties of this databases. So we have this as 5.7 version MySQL. And if we look at the available resources, so there are around 10 databases in here. And then let's look at the metrics. There are various metrics to verify. But for example, let's take a look at storage used, for example. So that is around 150 GB. And this we could use for comparison after we have done the migration, right? So now let me invoke the Azure CLI, and then we would use the command line argument for this demo. So this would be MySQL import CLI command. So that has few parameters, as you can see, which is data source type. In this case, our source is single, so MySQL single, then data source name, then the resource group where this data source resides. And lastly, the name is the flexible server name. So these are the parameters that we would use for the MySQL import command. Right. So once we run this command, you would notice you would see IOPS in terms of the execution of this migration, and would of course depend on your storage size and SKU. It also detects with the smart default on what is the target SKU. So in this case, I detected standard D2, DS, V4 pay tier for comparable SKU. It also updates the connection string that you can use to update your applications once you have migrated, right, to connect to the new application now. So it provides you those connection string as well. Let's also notice the SKU name and the version of this, which is still 5.7. Now, we also want to verify the flexible server details to see whether it has been migrated properly. So you can see you can see an entry of flexible server in the ECS location. Like before, the version is still 5.7. We will look into that separately, but first look at the databases that were there. All of those resources have been migrated. Let's also verify the metrics. So again, back to the storage used for the migrated server, and we should see more or less, yeah, we have a comparable size so that all data has been migrated, right? Now, the other important aspect is to get back to the upgrade scenario, right? So we know that this is 5.7 and we have to upgrade this to higher environment. So we have an upgrade experience in the Azure portal itself. So you would see an upgrade icon on the top. You can click there, and you have your current version and your target version that you want to upgrade. You must also verify using MySQL upgrade checker tool to test your compatibility. So we have a validate experience here also embedded. If we click on that, it will highlight all the compatibility issues. For example, let's say in this particular database, Aquila, you have these functions or syntaxes used which is not supported, or this is global server parameters, 0 date and time, which are not assigned. So that needs to be remediated. And there are other like functions, etc., which are being used that would need to be remediated. So we'll follow a two-pronged approach. So we would correct some and we would drop one of the databases. Of course, you would, in real world, you would fix that and rerun the upgrade. So given the time constraints, we will drop Aquila from here. And then we will go back to the server parameters to remediate other observations there. So I would type SQL mode, and here we would set the global parameters for the exceptions that we got on the 0 date and the 0 end date. So these you have to select and then save. Once you hit save, it will invoke the deployment because the ARM template gets deployed behind the scene. And once that is deployed successfully, we can reinitiate the upgrade to 8, right? But before we upgrade, let's also go back to the resource and look at if there are any more exceptions, right? Just to be double sure. So we would click on validate again, and we should hopefully not have any exceptions. So this is good to go now. Those remediations have helped. So let's click on migrate now, upgrade now to version 8 from here. So once you invoke that, the deployment will begin, and depending on again the size and memory and the bandwidth, it will take certain time. So we have trimmed that out from the video, but once the deployment is completed, we can go back to the flexible server, which is the migrated server just now, to see whether the upgrade also has been done correctly or not, right? So we can go back to the resource and just quickly verify the version and probably the storage size. So you can see it's version 8.0 now, and we can look at the databases. We have all the databases minus the one we dropped, and then we can also look at the metric. Again, back to storage used, and the memories should be comparable. Yeah, around still 160 GB. So the upgrade has been done. So yeah, this is all I had for today. We wanted to showcase very quickly how easy it is to use MySQL import, and it is very performant. And you have validate options for upgrade easily as well. So this kind of covers if you have to migrate from lower version to the higher version, and also upgrade in that same context. So I would just close by reiterating that the success of a seamless migration would lie in thorough preparation, comprehensive testing, and ongoing performance monitoring. Right. With that, you are basically now ready to make the move. So that's all I had to share today. Back to you, Jim.
Hey, thank you so much, Gyani. I really appreciate you sharing these tips and tricks with us. Folks, you can learn more by taking a look at Gyani's blog at aka.ms/MySQL singles to flex server strategy. And you'll figure out how to upgrade your servers right away. Thanks again to Gyani for taking time out to be with us so late in your day and for sharing your expertise. We really appreciate that.
Thank you.
All right. We're going to go ahead and move on to our second topic of the day. Some of the most common issues faced while accessing your database from different sources and networks are connectivity issues, especially when you want to keep the connection secure and isolated. We're going to bring on Ravi Shankar, who's a support escalation engineer at Microsoft, and he's going to walk us through how to troubleshoot connectivity issues while connecting to flexible servers in a private network configuration. Welcome, Ravi. Thanks for joining us today. Can you tell us a little bit about yourself?
Hello, Jim. Thank you for having me here. And I am Ravi, one of the support escalation engineers at Microsoft. Today, I would be discussing about connectivity issues faced by us while setting up private network configuration. So,
Fantastic. Ravi,
yeah,
thank you. I'm going to go ahead and let you take the spotlight at this point.
thank you, Jim. So, in the next slide, I would be talking about various scenarios we use in our network configuration. And so, we are going to cover like 4 scenarios connecting when we are in the same VNet, different VNet connection, hub and spoke model, which is widely used by our customers, and on-prem to Azure connectivity, how to establish that, and what problems we face while setting up all these connections. So moving on to the next slide. So we already know that our flexible server is a fully managed enterprise-ready service with high performance scalability and security. And while connecting to the server, we do face a lot of access issues when we are connecting from various sources like VMs, AKS, or app service. And we have step by step for common scenarios like I have mentioned earlier, uh, from the same VNet, different VNet, hub and spoke, and also from on-prem. So in the next slide, I'm going to start with same VNet configuration. Next slide, please. So if we are thinking of connecting from the same VNet, the source VM and the MySQL, Azure MySQL managed service is on the same virtual network. Then the common scenarios what we face is like the VM not getting connected to MySQL database, and that is that can be checked at 2 levels. One is our NSG, which has to be checked if NSG is properly configured for the connectivity from the source to the target Azure database MySQL. And second is the route table. So in the route table, we generally tend to introduce our firewalls, proxies, so that we can inspect the connections going to and fro. However, many times we do not tend to provide exceptions, and that can be checked using the firewall logs. So if we are checking the firewall logs from the firewall mentioned in the route table, definitely that is going to help us identify that whether the connection is moving to and fro, and and the connectivity can be established by giving proper exceptions at the firewall. Moving on to the next scenario in the next slide. So coming on to different VNet connectivity. So generally, we have seen that customers keep their VMs or the source in a different VNet, and Azure database for MySQL in a different VNet. And once they try to establish connection, they might face connectivity issue. So during that time, what I suggest is that we need to first check the first scenario, that we do have proper firewall exceptions at the firewall introduced at route table on both the sides. And second, we need to check the peering. peering between the VNets. So that we do have a demo for this, and to check whether the proper peering is between the source VNet and the target VNet. And if there is a proper peering and the uh, route tables do have proper exception, NSGs are set up with correct rules, we will not face the connectivity issue. Moving on to the next scenario. So we have hub and spoke model, which is widely used on Azure. And with hub and spoke model, we have a centralized location where the connectivity is managed at the hub level, which is connected to multiple spokes as in different VNets. The source can be on a different VNet, which is connected to the hub, and the Azure database for MySQL would be connected to the hub as well. The hub is the location from where the connectivity is managed. So, in order to verify the connectivity, we need to ensure the first two points, as in what I had suggested on the first slide, that is NSG on the hub as well as on the spokes of the source and the target. So here the source would be the VM or AKS, like I said earlier, and the target would be Azure Database for MySQL. And also, we need to check that there is a peering established between the hub VNet and the spoke VNet, so that the connectivity and the flow is mentioned. We also need to ensure that there should be proper firewall exception if we are using multiple firewalls, let's say, on the spoke of the source or at the target, and also on the hub. So those exceptions need to be given at all the firewall ends. We should go ahead and check each firewall if there are multiple, and if there is a single firewall present at the hub level where all the connectivity is going, then the firewall logs are very useful in order to identify that whether the packets are flowing in and out of the firewall and from source to the target. So providing IP in order to check the firewall logs for the source and the target would give us would tell us that whether the connectivity is getting established altogether. Moving on to the next slide. So this is a scenario where we tend to connect from on-prem servers or on-prem VMs, I would say, to the Azure private network. And in that case, a VPN is very important. So generally, the scenario is that we have a centralized hub which manages the VPN, and we have a VPN device at our on-prem network, which tends to establish IPsec tunnel for the connectivity from the on-prem devices to the Azure network. So at on-prem level, we need to first confirm that the connectivity is set up with the VPN devices. Second, if we have an on-prem firewall, which generally we tend to see with all the customers, the connectivity should be allowed from our on-prem network to the Azure private network. Also, there shouldn't be a firewall at Azure level which would be blocking the on-prem connectivity. So we need to provide exceptions based on our subnets which are present on-prem, as well as we need to provide exceptions on the firewall present on Azure as well for the on-prem network. Similarly, we need to provide exceptions at our on-prem firewall for the Azure network, and that would remove one of the constraints. Other constraint which can come in this scenario would be like the NSGs at spoke level, NSG at hub level, and if there is a VPN connectivity issue. So generally, in this case, we tend to use site-to-site connectivity, site-to-site VPN, which gives us a proper network scenario where the connectivity can easily be established. And so if we inspect all these aspects in a connectivity scenario, in all the four scenarios, whatever we had discussed, NSG, routes, firewalls, as well as the certificates, on-prem firewalls, then we can establish the connectivity from any scenario, whatever we had discussed. We will move on to demo. So taking first the database into into consideration, if we go on to the networking part of the database, we see that it is in a virtual network called testing VNet 1. And that that and checking the VM, which is also present in the same network or in the same VNet, I would say, testing VNet 1. And we will try to establish connection from the VM to the database and check what all constraints we might face. So the database is present in MySQL Flex subnet, and the VM is present in the default subnet. Here, we do not have any firewall rules here, or as we can see the route table and the NSG, which is present here. So going on to if we try to establish the connection, setting up the connectivity and providing the password in like connecting to the terminal from the VM, uh, it tends to like go ahead and it might time out. Let's see. So we do see that the connectivity could not be established here. So going to the private DNS zone, which is created while the server was created, we have to find the IP address for the database. And here we can see multiple IP address. However, I know my server is having this particular CNAME, but how can we check that what is the actual CNAME if the same private DNS is being used for multiple MySQL databases? So in that case, we can connect to the Azure CLI and then try to run NSLOOKUP for the server name. So here, using the terminal or using the Azure CLI, I would say that I tried to go ahead and run this NSLOOKUP for this particular server. And the result, what we got is the CNAME record as okay. And as soon as we hit enter, we get the actual canonical name, which is present on our private DNS zone. So that would bring us the actual IP being used for the database. So the previous scenario, we were using the name and it failed because of a different reason, which we would take in a different session. Okay, so for now, I'm just using the IP address in order to connect to the database. And and let's use the IP address MySQL-H, and instead of the server name, I would provide the IP address. So let me remove and then paste the IP here. Perfect. Yeah, I would provide the password and let's see that whether the connection is getting established or not. Yeah, perfect. So right now the connectivity is getting established. Earlier, the problem was different. Uh, Probably it was a DNS issue, which would be taken further in a different uh, webinar, I believe. So, so we have set up the connection between the same VNet, and earlier we had seen that it is it was using a security group and a route table. So right now we have a security group and a route table in the same VNet, and we would check the connectivity for this once again. Providing password. It tends to like time out, okay, because of the security group or whatever constraints are present. There would be a blockage at the security group or the route table, which contains a firewall IP. Using that IP, we can reach to the firewall and check the details, like the live logs at the firewall would give us some input that whether it is being blocked by some rule or something, and eventually we will have to provide firewall exceptions, or if it is blocked by the security group, we need to provide exceptions. So the best way to test here is using CLI and private DNS zone, and then going ahead with the like using the IP address in the connection string in order to connect to MySQL. So we are seeing that it takes a lot of time here in order to connect. And like there is a chance that it might fail.
Hey Ravi, looks like the demos ended, and that was it. That was shared. Was there more to the
Mhm.
demo? Would you want to share it on a different platform? Because I know you do have a blog written as well. Would we
Mhm.
want to put the rest of the demo in the blog?
Yeah, I would be adding rest of the demo in the blog so that it is useful for our customers.
Perfect. Thanks so much, Ravi. So sorry about that, and I'm not sure where the rest of the demo has
Thank
gone on
you,
to.
Shreya.
Yeah,
Mhm.
but
Mhm.
yeah, thanks so
Hey,
much, and yeah,
yeah,
I do.
really appreciate your time, Ravi. Despite the little hiccup here, thanks for your insightful troubleshooting tips in the demo. And folks, be sure to check out the blog, Ravi's blog that Shreya mentioned. And thanks again, Ravi. I know it's late in your day, and we really appreciate you taking part in this webinar for us.
Thank you, Jim. Thank you, Shreya. Thank you for having me here.
You're welcome. Thank you. All right. we're going to move on to our final topic of the day. Shreya, could you go ahead and share the latest roadmap for Azure Database for MySQL with us?
Yeah, for sure. Just give me a second there. Perfect. So we've got a bunch of items in the latest feature roadmap, not many announcements this time, but here's how the roadmap looks. First, accelerated logs feature for business critical SKU, with which you can see up to 2x performance enhancements at no additional cost. With this feature, like I've mentioned before, we also see a significant performance and price performance enhancement over AWS RDS, Aurora, and GCP. Now, my Azure Database for MySQL accelerated logs will be in general availability this month itself. In fact, in very close timings around around Microsoft Build. So watch out for the announcement during Build 2024. Going GA along with accelerated logs is the support for 32 TB storage. Currently in private preview, this feature gives you the ability to expand your storage for business critical SKU up to 32 TB. Along with accelerated logs, this will also go GA around the build timeframe. We've got another feature, on-demand backup and export, which is again currently in private preview and provides an ability to export at moment physical backup of the server to Azure storage account, which is Azure Blob Storage, using Azure CLI. Once exported, these backups can be used for data recovery, for migration, for data redundancy and availability, or even auditing and other purposes. We plan to release it in public preview this month as well. The MySQL import CLI for external migrations, again, currently in public preview. This tooling, like Gyani showed earlier today, allows you to perform, is just a single CLI command, right? While Gyani showed how you can use MySQL import CLI for migrating from single to flexible, we also have the ability to migrate from on-premises or VM workloads onto Azure Database for MySQL Flexible Server. It is so fast that you can actually migrate around 1 terabyte of data in just around 23 minutes. Azure MySQL import for external migrations actually uses your physical backup copy, which you can obtain through Percona Extra Backup and store in Azure Blob Storage. It uses this physical backup copy to provision and restore to MySQL Flexible Server. The feature will also be GA'd in this quarter. Next is a set of 3 maintenance-related features. First, flexible maintenance options, which allows you to reschedule maintenance windows and even instantly initiate maintenance with a reschedule now option. It will be GA'd this quarter. Near zero downtime maintenance for HA-enabled servers. Now, this feature is designed to reduce the maintenance downtime for HA-enabled servers, ensuring that, or in most of the cases, the downtime is around 40 to 60 seconds. And this is especially critical for businesses that really can't compromise on HA and require minimal interruption in their DB operations. This will be GA'd in this quarter as well. Third is virtual canary. This might be the first time that we're talking about it in this forum. With this new feature, which is releasing in preview this quarter, you can opt your development, testing, or staging servers to be in virtual canary. Servers in virtual canary will receive monthly updates in advance, and it kind of gives you an opportunity to perform another additional layer of testing of these updates on top of whatever testing that we already perform internally. It helps you to provide another test to avoid issues specific to your workload, like application level compatibility issues, etc. So it's essentially an efficient way to manage your updates, align your testing and your production environments, and make sure that there is operational stability with no disruption during these maintenance windows. The last 3 features have upcoming milestones in early Q3 of calendar year 2024. Error logs and server logs. The feature provides you the option to view and download error logs under the server logs option for up to 7 days to analyze and troubleshoot issues. Long-term retention of backups, which is now in public preview. Previously, Azure Database for MySQL allowed for automated backups and on-demand backups to be retained up to 35 days. With long-term retention, you can now retain the backups up to 10 years, which will further aid your auditing and compliance needs. Both error logs and LTR, long-term retention of backups, are currently in public preview and will be GA'd early next quarter. Finally, MySQL discovery and assessment in Azure Migrate, like Gyani called out earlier today, discovery and assessment is the first first pillar in your entire migration process, right? So with this functionality, you can actually use Azure Migrate service to discover your MySQL servers in your environment, to assess them by identifying their compatibility, to move to Azure Database for MySQL, and also receive storage and compute SKU recommendations along with their costs. This is currently in private preview as well, and we're planning to go to public preview next quarter. But if any of you want to try any of the features in private preview, do write to us at askazure.db for MySQL at service.microsoft.com. Now, we'll also publish all of these in a monthly update blog like we have been doing for the past couple of months. It will contain all the updates of each of these features in it. We usually publish this around 2 days after the webinar, so you can look for the latest, for the next update to come by the end of the week or early next week. And you can find those updates at ak.ms MySQL monthly update. Now, one final thing to share, Microsoft Build is here. So don't miss our demo session that where we'll be demoing some exciting new features, not just the ones that I showed you in the roadmap, but there's one other that we are going to be announcing as well at Build. So register today and we'll see you in Seattle. That's all from my side, Jim. Back to you.
Hey, thank you so much, Shreya. Really appreciate that. Folks, that's pretty much all we have for today. As we close out, I'm going to leave you with 4 things to keep in mind. Shreya, can we go to the next slide? First is about our contributors program. If you're not already a member, please sign up. It's not difficult. You can go to this link and or check out the QR code there. And it's very easy. We have 3 different levels that you can join. It's very easy to start. And as you work your way up, you'll get to produce content and perhaps even work with us to collaborate on particular titles. Next, I want to make sure that you check out the MySQL resources link to learn more about our service. These resources are great, and you can feel free to reach out to us on our email ID if you have any questions. Third, stay tuned for more updates and announcements by following us on social media and subscribing to our YouTube channel. Our handle on YouTube and Twitter is at AzureDB MySQL. And finally, if you want to feature in our upcoming webinars or collaborate with us in any way on collateral, please take time to fill out the feedback form we've got. You can also use that form to provide suggestions for future topics that you might want us to cover and that type of thing. So with that, I'm going to thank everybody for tuning in. And we hope you enjoyed this episode, and we'll look forward to seeing you at our next session on the 12th of June at 7:30 a.m. Pacific time. Thanks everybody for your time today. Appreciate it.